In last lecture, we have studied the variation in the value of g. Now the next concept related to the gravitation, it is the free fall. Now the there is one activity in your book. In this activity, if we hold a ball in our hand, there is a force of gravity on this ball, but we are holding it in our hands. Therefore, our hands apply the forces balancing to it. If we release it, it will fall. It will fall down towards the ground in downward direction, in the direction of gravitational force. Now, when this ball falls due to gravity, there are some other forces there acts on this ball or any object falling towards the ground. There is a force of friction due to air. There is a buoyant force acting on this object, and therefore in air truly there is no actually the free fall. Free fall occurs only in vacuum, because whenever the object is falling under the influence of gravitational force alone, then it is said to be freely falling. फ्री फॉल म्हणजे मुक्त पतन. एखादी वस्तू आपण हातात धरली असेल तर तिच्यावरती ग्रॅव्हिटेशनल फोर्स असतच. आपण सोडली तर ती ग्रॅव्हिटेशनल फोर्समुळे अधोगामी दिशेत खाली पडते, जमिनीवर पडते. पण त्यावेळी सुद्धा हवेचं घर्षण बल त्याच्यावर कार्य करत असतं. त्याच्यानंतर बॉयंट फोर्स म्हणजे प्लावक बल त्याच्यावर कार्य करत असतं. म्हणजे इतर काही फोर्सेस त्याच्यावर कार्य करत असतात आणि त्यामुळे ह्या पडण्याला मुक्त पतन असं म्हटलं जात नाही. मुक्त पतन प्रत्यक्षात कधी होऊ शकतं तर निर्वात पोकळीमध्येच हे होऊ शकतं. म्हणजे काय, जेव्हा एखादी वस्तू फक्त गुरुत्वाकर्षण बलानं खाली येते, खाली पडते, त्या पडण्याला मुक्त पतन असं म्हणतात. द फ्री फॉल व्हेनेवर an object moves under the influence of force of gravity alone, it is said to be freely falling. Whenever the object moves under the influence of force of gravity alone, it is known as freely falling. Now the next thing is that it can possible only in vacuum. The next thing related to it, for a freely falling object, velocity on reaching to the ground, the time required to reach the ground, we can calculate these quantities related with the freely falling objects. And now we can use the Newton's equation of motion for this calculation. Whenever object is freely falling, it is initially it is raised to position, and therefore for freely falling objects the initial velocity u is equal to 0. It is falling due to gravitational force, therefore its acceleration is acceleration due to gravity, that is g. And then by the Newton's equations of motion, we know the Newton's equation of motion. The first equation is v is equal to u plus at. S is second equation of motion. S is equal to ut plus 1/2 at square, and third equation v square is equal to u square plus 2as. Now whenever the object is freely falling, it has gravitational acceleration, then this equation changes to a is replaced by g. U is the initial velocity, that is 0 for freely falling object, and this relation or this equation is written as v is equal to gt. This equation, the second equation of motion, it changes to s is equal to 1/2 gt square, and third equation changes to v square is equal to 2gs. Now there is one another thing related to, is that if the motion of an object is thrown upward direction, the velocity goes on decreasing, the acceleration due to gravity, it is taken as minus g. This is the sign convention when any object is thrown in upward direction, because it moves opposite to the direction of the gravitational force. This is about the free fall. Now there are some examples in your book related with the free fall. We have to solve these examples. The first example, read it carefully, then we will solve it. The first example is that an iron ball of mass 3 kg is released from a height of 125 meter and falls freely to the ground, assuming that the value of g is 10 meter per second square. Then calculate. There are three sub-questions for the calculations. The first is time taken by the ball to reach the ground. Second, velocity of the ball on reaching the ground. And third, the height of the ball at half the time it takes to reach the ground. म्हणजे इथं आपल्याला काय सांगितलेलं आहे, एक लोखंडी गोळा 3 kg वस्तुमानाचा गोळा 125 मीटर उंचावरून सोडला असता खालील 3 गोष्टी आपल्याला कॅल्क्युलेट करायच्या आहेत. जी दिलेलं आहे आपल्याला, पहिली गोष्ट काय काढायची आहे तर जमिनीवर पोहोचण्यासाठी लागणारा वेळ. दुसऱ्या सब क्वेश्चन मध्ये जमिनीवर पोहोचत असताना व्हेलॉसिटी काय असेल, आणि तिसऱ्यामध्ये जो वेळ लागतो त्याच्या निम्म्या वेळेत त्या बॉलची जमिनीपासूनची उंची किती असेल. एवढ्या 3 गोष्टी आपल्याला ह्याच्यामध्ये शोधायच्या आहेत. कुठलेही एक्झाम्पल सोडवत असताना दिलेल्या एक्झाम्पल मध्ये आपल्याला काय माहिती मिळाली ती अगोदर लिहून घेतली म्हणजे आपल्याला सोडवणं सोपं जातं. त्यामुळे पहिल्यांदा आपण गिवन थिंग्स लिहायचे आहेत. इन दिस एक्झाम्पल गिवन थिंग्स mass m is equal to 3 kg, then height from which it is released, this is nothing but displacement of the ball, it is 125 meter, then g is given 10 meter per second square, and it is released, the iron ball is released from this height, that is initially it is at rest position, therefore its initial velocity is taken as 0 meter per second. Now in first step question we have to calculate time required to reach the ground. Second, we have to calculate velocity when it is reaches to the ground. And third, we are going to calculate the height of the ball from the ground when it is in half time. In half time. These three quantities we have to find out. Now the first, for all these calculations we need the Newton's equations of motions, and therefore we can write here again the equations of motion, that is v square is equal to u square. We can write here equations of motions. The first, v is equal to u plus at. Second, s is equal to ut plus 1 half at square, and third, v square is equal to u square plus 2as. आपल्याला इथं न्यूटनच्या गतिविषयक समीकरणांचा उपयोग करूनच ह्या 3 गोष्टी शोधायच्या आहेत. आणि आता पहिल्यामध्ये टी शोधायचं आहे. मग टी साठी आपल्याला यू माहिती आहे, जी माहिती आहे, एस माहिती आहे, आणि मग या गोष्टींचा वापर करून सोडवण्यासाठी कुठलं इक्वेशन आपल्याला उपयोगी पडेल ते आपण वापरायचं आहे. इथं आपल्याला टी काढायचं आहे. सेकंड इक्वेशन आपण वापरू शकतो. ह्या पहिल्या एक्झाम्पल सोडवताना युजिंग second Newton's second equation of motion, Newton's second equation of motion, we can write here S is equal to ut plus 1 half, we can replace a by gt square. Now we know the value of s, it is 125 is equal to u is 0 into t plus 1 half into 10 into t square. Here 2 5s are 10. Then we can write the next next step, 125 is equal to 5t square. Therefore, t square is equal to 125 divided by 5, and therefore t is equal to t square is equal to 25 and t is equal to 5 seconds. That is the first answer. The time taken by the ball to reach the ground is 5 seconds. Now the second. In this second question we have to find out the velocity. दुसऱ्या सब क्वेश्चन मध्ये आपल्याला velocity of the ball on reaching the ground काढायचे. तो बॉल जमिनीवर पोहोचता क्षणी त्याची velocity किती असणार आहे, पोहोचतो त्यावेळी किती velocity असेल, हा भाग आपल्याला शोधायचा आहे. आणि इथं आपल्याला पुन्हा कुठलं इक्वेशन वापरायचं याचा विचार करायचा आहे. आपल्याला इथं a माहिती आहे, t आता इथं माहित झाला, त्यामुळे इथं फर्स्ट इक्वेशन आपण वापरू शकतो. म्हणून इथं सेकंड एक्झाम्पल सॉल्व करताना युजिंग न्यूटन्स फर्स्ट इक्वेशन ऑफ motion we can write v is equal to u plus gt. Now v is equal to u is the 0 plus 10 into the time is 5 seconds. Therefore v is equal to 50 meter per second. Now the third, that is h is equal to s in half time. The third sub question is that the height of the ball at half the time it take to reach the ground. म्हणजे अर्ध्या जेवढा वेळ लागला त्याच्या अर्ध्या वेळेत खाली येत असताना तो जमिनीपासून किती उंचीवर आहे, हा भाग आपल्याला सोडवायचा आहे. म्हणजे तिथं पण आपल्याला डिस्प्लेसमेंट काढायची आहे आणि वरून किती खाली आला तेवढं काढायचं. म्हणजे त्या उंचीनुसार त्याच्यानुसार आपण जमिनीपासून किती उंचीवर आहे हे आपण काढू शकतो. आणि त्याच्यासाठी पुन्हा आपल्याला डिस्प्लेसमेंट म्हणजे सेकंड इक्वेशन ऑफ मोशन हे वापरावं लागणार आहे. म्हणून इन थर्ड using Newton's third equation of motion, we can write s is equal to ut plus 1/2 gt square. Now here u is 0 into t is we have to take here time, that is half of the time, that is 5 upon 2. For this t is equal to 5 upon 2, that is equal to 2.5 seconds, and therefore 2.5 plus 1/2 into 10 into 1/2, the value of g is 10, 1/2 into 10 into 2.5 square. Now 2 5s are 10. We have to take the time, half of the time which is required to reach the ground. जमिनीवर पोहोचण्यासाठी 5 सेकंद लागतात. त्याच्या निम्मा वेळ म्हणजे 2.5 सेकंद इथं टी घ्यायचा आहे. आता इथं s is equal to 5 into 2.5 square, that is 6.25. Therefore s is equal to 31.25 meters. That is in 2.5 seconds it comes towards the ground in the distance 31.25 meter. Then we are going to calculate the height of the ball from the ground. म्हणजे 2.5 सेकंदामध्ये तो बॉल वरून खाली 31.25 मीटर एवढं अंतर खाली येतो. तर त्यावेळी तो जमिनीपासून किती उंचीवर असेल. एकूण ह्या बॉलचं विस्थापन डिस्प्लेसमेंट हे 125 मीटर आहे. त्यामुळे 125 मीटर मधून हे अंतर वजा केलं की जमिनीपासून बॉल किती उंचीवर आहे, हाईट ऑफ द बॉल इन हाफ ऑफ द टाइम, हे आपल्याला मिळेल. आणि म्हणून इथं आपण काय करायचंय, द हाईट ऑफ द बॉल, द हाईट of the ball at half time is equal to 125 minus 31.25. It is equal to 93.75 meters. This is the answer. Thus, this is the example related for the concept of falling object. Now, example second on page number 12. I will read it. Listen carefully, or you can rewrite in your notebook. A tennis ball is thrown up and reaches to a height of 4.05 meter before coming down. What was its initial velocity? How much total time will it take to come down? म्हणजे काय, एक टेनिस बॉल वर फेकलेला आहे आणि तो खाली पडण्यापूर्वी 4.05 मीटर इतक्या उंचीवर पोहोचलेला आहे आणि तिथून तो खाली पडतो. तर पहिल्यांदा आपल्याला काय काढायचंय, वर फेकत असताना त्याची सुरुवातीचा वेग किती होता हे काढायचं आहे. आणि दुसरा भाग ह्याच्यामधला काय आहे, तर वर जाऊन खाली येई तोपर्यंत त्या बॉलला किती वेळ लागेल हा भाग आपल्याला इथं शोधायचा आहे. Now for upward motion, there is a ball is thrown in upward direction. Therefore, for upward motion, we have to write some things. For upward motion, when ball is thrown in upward direction, when it reaches to some height, its velocity becomes 0, then it starts to fall. Therefore, its final velocity is 0 meter per second. This is one thing. Then the distance traveled by the ball, it is S, it is equal to 4.05 meter. Then later on the G, gravitational acceleration, it has acceleration but it is thrown in upward direction, and by the sign convention it is taken to be negative, because when any object goes in upward direction its velocity goes on decreasing, and therefore acceleration A is equal to G, it is taken as minus 10 meter per second square. And we have to calculate the velocity, initial velocity, that is u, we have to calculate, and later on we have to calculate the time t, total time. We can write t1 time to come down, and plus t2 time to go up, म्हणजे वर जाण्यासाठीचा लागणारा वेळ अधिक खाली येण्यासाठी लागणारा वेळ, असं एकूण वेळ किती लागला हे आपल्याला शोधायचं आहे. म्हणून याच्यासाठी आपण क्वेश्चन मार्क देणार आहे. नाउ द फर्स्ट पार्ट वी आर गोइंग टू फाइंड u, we know a, s and v. v माहिती आहे आपल्याला, s माहिती आहे आणि g माहिती आहे. त्यामुळे आपल्याला कोणतं इक्वेशन वापरायचं ह्याचा विचार करायचा आहे. We can use the third equation of motion. Then using Newton's third equation of motion, we can write v square is equal to u square plus twice gs. V is 0, that is 0, then 0 is equal to u square is to be calculated plus 2 into minus 10 into 4.05, then 0 is equal to u square minus, here we can multiply this, then it will get 81 0.81 sorry u square minus 81. Then u square is equal to 81 and therefore u is equal to 9 meter per second. This is the initial velocity. Therefore unit is meter per second. That is, it's when it is thrown, a ball is thrown in upward direction, its initial velocity is 9 meter per second. जेव्हा एखादा हा बॉल वर फेकलेला आहे तेव्हा त्याचा सुरुवातीचा वेग हा 9 मीटर प्रति सेकंद असा आहे. आता याच्यानंतर आपल्याला तो बॉल वर जाऊन खाली येईतोपर्यंत किती वेळ लागतो, किती वेळ घेतो, हा वेळ काढायचा आहे. आणि पुन्हा आपल्याला याच्यामध्ये न्यूटन्स इक्वेशन ऑफ मोशन वापरायचं आहे. पण इथं बॉल वर पण जातो आणि बॉल खाली पण येतो. या दोन्हीपैकी एक कंडिशन विचारात घेऊया. याच्यामध्ये आपण काय कन्सिडर करणार आहे? त्या बॉलची डाऊनवर्ड मोशन कन्सिडर करणार आहे. म्हणून सुरुवातीला मी इथं लिहिते, नाऊ कन्सिडर downward motion of ball. वर जाऊन तो खाली येतो, त्यापैकी खाली येणारी कंडिशन आपण विचारात घेऊया. आता हा बॉल खाली येत असताना वरती त्याची व्हेलॉसिटी 0 होते आणि तिथून तो खाली पडायला सुरुवात होतो. म्हणजे वरून खाली पडण्याची सुरुवात याच्यासाठी इनिशियल व्हेलॉसिटी ही 0 असणार आहे. तिथं पोहोचल्यानंतर तो खाली येण्यास सुरुवात करतो. ही डाऊनवर्ड मोशन आपण विचारात घेतोय आणि त्यामुळे इथं उंचावरून पडायला सुरुवात होत असतानाची जी व्हेलॉसिटी आहे त्याला आपण इनिशियल व्हेलॉसिटी म्हणणार आहे. आणि ती आपण velocity becomes 0, then it starts to fall. Therefore here we are going to take the initial velocity u is equal to 0 meter per second. Therefore now consider downward motion of the ball. Therefore u is equal to 0 meter per second. Now we know the we are going to a downward motion. The time t1 we are going to calculate. We know the value of s, we know the value of u, we are going to find out t, we know the a, and then we can use the Newton's second equation of motion. Using Newton's second equation of motion, s is equal to ut plus 1/2 gt square. Then s, the value of s is 4.05 is equal to u, the velocity u, it is 0 into t plus 1/2 g. For downward motion g is always positive. For upward motion it has to take negative, but we are going to consider here downward motion, therefore g is positive into t square. Now we are going to calculate time to come down. It is denoted by t1. Therefore we can write here the time as t1. आपण खाली पडतानाची सिच्युएशन विचारात घेतली त्यामुळे t1 लिहूया इथं. आता याच्यामध्ये 4.05 is equal to 0 plus 2 5s are 10. Therefore 5 t1 square. Then we can write here t1 square is equal to 4.05 divided by 5. t1 square is equal to 0.81 and therefore t1 is equal to 0.9 seconds. That is time required to come down the ball, to reach the ball on the ground. It is 0.9 9 सेकंद म्हणजे तो बॉल जमिनीवर खाली येण्यासाठी लागणाराचा वेळ जो आहे तो 0.9 सेकंड्स आहे. जेवढा येण्यासाठी वेळ लागतो तेवढाच वरती जाण्यासाठी वेळ लागत असतो, कारण G is always same. G is always same, and therefore we can write here T1 is equal to T2 is equal to 0.9 seconds, and total time to go up and come down, it is 0.9 plus 0.9, it is equal to 1.8 seconds. The total time required for the ball to go up and come down, it is 1.8 seconds. This is about the examples related with the free fall. Now in next lecture you will study the gravitational potential energy and escape velocity, but before that आता पुढच्या कन्सेप्ट अभ्यास पूर्वी हीच कन्सेप्ट तुमची चांगल्या पद्धतीने क्लिअर व्हावी याच्यासाठी एक प्रेझेंटेशन मी तुम्हाला दाखवणार आहे, तर ते पहिल्यांदा मी पहा.
Free fall. Try this. Take a small stone. Hold it in your hand. Which forces are acting on the stone? Now release the stone. What do you observe? What are the forces acting on the stone after you release it? We know that the force of gravity due to the earth acts on each and every object. When we are holding the stone in our hand, the stone was experiencing this force, but it was balanced by a force that we are applying on it in the opposite direction. As a result, the stone remained at rest. Once we release the stone from our hands, the only force that acts on it is the gravitational force of the earth, and the stone falls down under its influence. Whenever an object moves under the influence of the force of gravity alone, it is said to be falling freely. Thus, the released stone is in a free fall. In free fall, the initial velocity of the object is zero and goes on increasing due to the acceleration due to gravity of the earth. During free fall, the frictional force due to air opposes the motion of the object, and a buoyant force also acts on the object. Thus, true free fall is possible only in vacuum. The moon and the artificial satellites are moving only under the influence of the gravitational field of the earth. Thus, they are in free fall. Do you know? The value of G is the same for all objects at a given place on the earth. Thus, any two objects, irrespective of their masses or any other properties, when dropped from the same height and falling freely, will reach the earth at the same time.